geometric solids. Exclamatory point. And these would be the things. First of all, really we break it into, well, there's 3 different categories. We are going to go with prisms. And pyramids. And the difference between the two, Wade Davis, is what distinguishes a pyramid from a prism? Anybody? What's a pyramid? Parker? Huh? Yeah, that's a good way to describe it. Pyramids come to a point. They are, as Parker says, pointy. This is Parker. Let's put that down in our notes because he says pointy. It doesn't even look like it spells pointy. Oh, it says Parker, doesn't it? All right. Prisms, on the other hand, are made of this, and the exact definition of that, it has parallel, congruent bases. And I suppose, I don't know if we have to talk about this today or not. Yeah, let's just see. Let's just look at a couple prisms. What shall we draw that? Let's go merge. For example, and really here's the easiest way to draw prisms. Let's say you're starting with a rectangular prism. That would mean its base is the shape of a rectangle. Now the thing with a rectangular prism, it's technically called simply a box in our whatever modern jargon, is that anything could be the base because it's all made up of parallel boxes that are the same. The other, it's not going to be the case for everything. Easiest way to draw a rectangular prism. Let's say I'm drawing a cereal box. You know, really, you start with the basic rectangle of the cereal box. And all you have to do, and you don't want to do this real dark, you could do it kind of sketch it lightly, is repeat this same exact rectangle, just a little bit over and a little bit up. You go like this, you go like this, same size rectangle, and then just connect the corresponding vertices. Now usually, you can't see some of the sides of that, so you usually have dashed lines that represent sides that you can't see, but they're there. I kind of made mine a little goofy there. Same thing, you can't really see this box. And then occasionally, every now and then, you can shade parts that you want people to see, or like, for example, I would maybe shade this. I would maybe, it's kind of wide to be shading. Shade this, and I would shade this maybe a different color. But it makes it stand out as a rectangular prism. And in this case, anything could be the base because it's made up of all parallel rectangles that are all alike. Opposite sides on rectangular prisms are like. You know, if you're drawing a shoebox sort of shape, shoeboxes are more like this. You know, you could draw, this is like the front of the box. And then you could draw the other rectangle the same size over here. And then you connect the dots. Is that the right one? No. Connect side, corner. You can do your dashed line here. What other line would be dashed? Well, this one over here would be dashed. And this one here would be dashed. And there's your shoebox sort of thing. That would be your rectangular prisms. Now, you ask, what about triangular prisms? Triangular prisms, you know, is going to be kind of the same thing. You start with a triangle. Let's go with the right triangle. And I just draw that same right triangle kind of over here. Same, try to get it the same size. And you connect corresponding corners. And bam. There is your triangular prism. Triangular, why is this not right? Prism. What's that?
It's in white.
It's not. The beauty of the board is this. Check this one out. I got a next door neighbor. Triangular prism. If that's not dark enough for you, do this. Wait, where'd it go? Oh. That's what I'm talking about. Now, the base on a triangular prism, listen to me. Focus to me on this. Okay? Have we talked about the loaf of bread theory? I think we have. No? When you're talking about a solid and you're talking about its base, you laugh, but this will make perfect sense in a minute. Everybody seems to think that the base is what it sets on, because when we do bases of things, like bases of statue, that's the thing it's set on. That's not the case with a rectangular prism or triangular prism or whatever solid. The base is what I like to call, you'll know it's the base, it is the loaf of bread theory. I came up with this for myself. The base is the shape that if that were a loaf of bread and you were trying to make a sandwich out of it, how would you slice it so that you get identical shapes so that your sandwich doesn't have a piece bigger on the bottom than it is on top? Which way would you slice a triangular pyramid or prism so that you would always get the same size sheet? If you sliced it with the square on the bottom, you kept slicing it this way, you would keep getting small and small rectangles till when you get up to here, you just get a little teeny tiny point. Right? If you sliced it like this, you'd get the same thing. What is the way you would slice it so that you'd always get the same piece, Evelyn?
So your triangles like this, you slice it like this.
It would be like this, so
Yeah.
you always get this. You are always going to get this triangular piece. And that is what the base is. This is a triangular pyramid because this little shape right here is the loaf of bread slice that you would get every time and get that same triangle over and over and over again. And then, children, not to throw you off any even more, this would be the base. The height, okay, everybody thinks that the height of the shape would be this, but it is not. The height comes from when you set it on its base. You have to then set it on its base, which would mean you'd have to take this, tip it over so that it's sitting on the triangle. What actually is the height of this shape? It is this distance from here to here. That is its height. Because the height and base, like in triangles, have to be perpendicular to each other. So you've learned something new. We will talk at length about that later on. Now, what if you're drawing an octagonal prism? One of my favorite shapes to try. Sometimes it works, sometimes it doesn't. Here we go. So I start with an octagon. This time maybe it won't work. And I just draw that same old octagon over here. And I connect the dots. Now these would be dashed back here. And you kind of get it. It would kind of look like that. Maybe I should have done a pentagonal one. You could just draw this like this. Get your pentagon. There's your pentagon. Not bad. Everybody good with that? Now, the other thing we have not talked about, let's define a couple things. When you talk about shapes, you have to talk about vertices. You have to talk about sides. And you have to talk about edges. What is the difference between vertices, sides, and edges? Actually, sides, I should have called them bases. Let's cross that off and say bases. What is a vertice? My little things are vertices. Wait, Davis. Yeah, they're the corners. Maybe you've heard of the Kendall County corners. If you're looking at this cereal box, how many vertices does it have? 1, 2, 3, 4, 5, 6, 7, 8. It has 8 vertices. What is a face? I kind of already alluded to that. A face is a side. So if you're looking at how many sides a cereal box has, you got the front, you got the back, you got this right side here, you got a left side that looks just like it, you got a top, you got a bottom. How many sides? It has 6, so this thing has 6 sides or 6 faces. And then what is an edge? If you've lost your edge, what have you really lost?
Intellect.
Advantage would be that, but that's not what edge is. What's an edge here, Parker? What's an edge?
Like the part of the cake that no one really likes.
That'd be the extra frosting. Faith, what's an edge?
Where two faces meet.
Exactly. Where two faces meet. So if you're looking at edges on this cereal box, you've got 1, 2, 3, 4, 5, 6, 7, 8, and you've got 9, 10, 11, 12. There are 12 edges on the unfair cereal box. Ain't that amazing, Gracie? How many edges on Mr. Triangular Prism there? Edges on Triangular Prism. Wade!
9.
3, 6, 8, 9. How many edges? How many vertices? Abram?
6.
6. How many sides? Parker? 4. Good. Look, we've made so much progress. I said it was going to be easy. All right. And then getting to our points. What's your point, you ask?
What's your point?
Points? My point is we're getting to pyramids, if I can find them. Where'd they go?
It won't find
Is it down here?
Yeah.
I thought it was at the top of my paper. There they are. Pyramids. Here is how you draw pyramids. You start with the base of what the shape is called.
With the triangular prism on 5 sides, because the one in the front, and then the one in the back, and the side, and the bottom, and the angle.
I don't know. Who told me 4? Yeah, that's fine. That's the last time we listened to Parker, kids. What's what? Let's look at that again.
Oh, yeah.
1, 2, 3, 4, 5. Yeah, I don't know what he was thinking.
Good, Rob. What's up?
Thanks for noticing.
They're almost the same.
I didn't want to make him feel bad, but he did. Anyways, back to pyramids. If you're trying to draw a square pyramid, here is how it works. Easiest way to do it, start with your square, except you have to think, because you're thinking 3-dimensional, it doesn't look like a square when it's sitting down, so you have to kind of think about it being like actually more of a rhombus kind of shape, because that's kind of what it looks like in a 3-dimensional world. You start with your square, and these can all be equal sides. Okay. Put a point above it, kind of centrally located, and then just connect that point with all the other vertices. In other words, you come straight down here, you come straight down here, you come straight down there. This back one you can't really see, so it's a dashed line, and there you have your square pyramid. Your square pyramid. If it was a triangular pyramid, again, start with your triangle. Put a dot up there, connect side, dot, dot. It doesn't look like much unless you kind of get rid of the dashed lines that aren't supposed to be there. You shouldn't be able to see this line. And then sometimes if you shade it, it helps a little bit. Where you can kind of shade this. You can kind of shade this. You can see the sides. It's a triangular pyramid. If it was a pentagonal pyramid, That gets a little goofy. Start with your pentagon. I don't want that one too wide. Start with your pentagon. Put your point up there. Connect down to your dots. And this would be shaded or off of here. It would work just as such. Everybody's good at that? So much to do and so little time to do it. What else do we have to talk about? Yes, cylinders. If you're not running on all cylinders, it's a car reference. Here's the way to sketch a cylinder. Just do this, draw a little oval on the bottom, draw the same oval above it, connect the dots, the sides. And there is your cylinder. Sometimes you can kind of shade it. I want it to look kind of shady. Cylinderish looking. Same thing if you want to draw a cone, which is nothing more than a cylindrical pyramid. Start with your base, put your point up there, connect the edges, and there is your cone. Cylinders right there, cone right here. And the last one, which could possibly be my favorite. Is it cold in here? There must be something in a sphere. Or a ball. What do we do? Because when you draw a sphere, you just get that circle. What can you do to Mr. Circle to give it a three-dimensional kind of feel, Evelyn?
Do that little
Do a little equator kind of thing, which just looks like this. This kind of gives it a little three-dimensional sort of a feel to it. Kind of shows people that it sticks out and goes in or whatever. Or, if you really want to get snazzy, you could shade it. Take this. How do you shade it? Do this little round thing. Any darker, it's not working. Leave that little round ball kind of looking thing. Usually it gets darker if you do it twice. How come this one doesn't get dark? Oh, there it did. I guess I have to take the pen off and do it. Keep getting darker? No, just two shades, huh? Oh, it looks like an eyeball, or a cue ball, or an eight ball. And then last but not least, what if you have spare time and you want to do something? How does that work, Wade Davis? Well, here's what you do. Start yourself off with a nice three-dimensional cube. Gives you a little bit of drafting class. One of my favorites in high school. Here's my cube. What if I wanted to take a little notch out of the top of it? How would that look? Oh, here, I'll show you. Start with the face. Let's draw a notch. Oops, sorry. Everything this way stays parallel with this side, and everything that way stays parallel with that side. Why doesn't that look like a notch? Well, because if really it's a notch, you have to cut the whole slice out of the middle of it. So you have to draw this part of the notch, and then you have to draw this part of the notch, and then you have to erase this little, oops, not that much. Erase this little middle section here. Erase this little section right here. But why doesn't that still look like a notch? Well, because you are still missing this piece that goes through here, and you're missing this piece that goes straight down. Now, ladies and gentlemen, you have yourself a little notch. That's spiffy. What if you wanted to put a hole in your little cube? Well, I'm gonna make it a square hole. But why doesn't that look like a hole? Because when you have a hole, what do you see? You will see this corner right here, which gets drawn parallel to that side. That looks like this. Does one see it? What if we wanted to take off like a whole chunk of this bottom thing? You watch, we go like this, we go like this, we go like this, and then we shall erase. Oops, that's not erasing. We shall erase. But why doesn't this look right? What am I missing? Always look at the corners. I need to continue this little line right here. Again, parallel to this line. And it's going to be that same distance back over here. Oops, extra one too.
It looks like a dinosaur.
I'm afraid it doesn't.
You should draw it.
What if I wanted to take out a whole corner piece right here? Watch. Boom, 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 boom. Give me a little eraser. Get rid of this. Now, why doesn't that look right? Because I have to take out, I have to draw this corner that you can see, that edge that you can see, and that edge that you can see.
It looks like a moving dinosaur.
There's no dinosaur.
I saw the dinosaur before. I more saw like a crossy road frog.
Yeah.
I've run out of options here. I could cut this off. This would be the easiest corner to take out. You can't see anything here.
What about a circle?
Well, a circle doesn't really give you a whole lot. You can do a circle, but what's it going to do? You can't see anything in there unless you kind of do one of these things. Not a whole lot that gives you a circle like that, unfortunately. A circle would look good if you could see all the way through it, and then you get the other half of the circle like this that you can see at the other end. But that's not right because it goes a lot deeper than that. You know what I'm saying, Vern?